Thank you, René. Hello to everybody. Like my colleague René just explained, I'm going to present the main feature and changes in the latest OpendTect version 4.2.0 as open and close commercial source. So the main topic I will be presenting are in open source, the improved 2D viewer. I will talk about what to do with 2D viewer, how it has been improved, how fault and horizon can be interpreted by dragging instead of making clicks seeds like we used to do before, and what can be displayed as 2D viewer, what kind of element. In fault interpretation, using our latest fault interpretation toolbar, I will show you how the user can create fault from faulty set, not by clicking and adding seeds, but just by dragging the mouse, and how a set of faulty set can be converted in fault, and the other way around, how fault can be inverted to faulty set. Another topic is export of cultural data to GoogleEarth. In that topic, data like survey boundaries, well surface coordinate, 2D line, polygon can be now exported from OpendTect to an Earth browser like GoogleEarth. I will further talk about directional lightning, wavelet tapering, sample multi-well import, how to import your multi-well in one go, improved managed stratigraphy, especially in the display, the time display versus the tree display. I will also talk about grading horizon using GMT algorithm, the Google Translate, how this allows the use of online Google Translator to enable the text translation from OpendTect. The multi-machine processing on Windows, we're doing it on Linux, but now Windows machine can be added as well. The topic below in white color are also new, but they have been covered by my colleagues in previous webinar. So I will take this opportunity to also tell to our new attendees that all previous webinars are available in DGB website. So they have been recorded and can still be viewed. So for those white topics, this include probability density function, support of Bayesian inversion, improved volume builder, or Wacom support. But I will also briefly talk about. In closed source, I will talk about local CCB, because we have a common countervening commercial plugin, but so far we were using what we call the standard way. Now we have the local one, and also, I will show you the new feature in common countervening, especially the display one, because we were displaying the flattened 2D viewer, but now we can also display the structural view. Pixel creation in neural network. While making your neural network training before, what we used to do is just to create pixel before starting neural network, but now for unsupervised neural network like UVQ, if you want to create your seismic phase map, you open your neural network window and directly you can create a random pixel from that window. I'll show you briefly. And here as well, the topic in white, in closed source, have been also in deep explained by my colleague in the previous webinars. Videos are online. So these include Horizon Cube, Wel Correlation panel. We have also a Petro link to exchange data from OpenTect to Petrol and vice versa. So let me start with in detail about the topic I just mentioned above. So the improved 2D viewer, what to get from 2D viewer? So the better visualization, you can see here, interpret fault and horizon by just dragging. I will show you the demo. We can overlay horizon cube, which has been created, and just you can overlay to see it in a better view. System track interpretation overlay as well. What element can be displayed in 2D viewer? Inline, crossline, random line. 2D line can be displayed in 2D viewer. We can also display the surface Z value or grid. Let's say you have create your seismic faces map and you want just to display it as 2D viewer with a north view. Pressure gather display in 3D scene can also be shown as 2D viewer, and attribute as like cap decon and spectral decomposition can be shown as 2D viewer. This is one example of the frequency, time frequency panel, TFP in the spectral decomposition attribute. So let me just go and show you a 2D viewer as a demo. So this is F2 demo Dutch block in the North Sea. I will display a line like 425. So here, by right click, I have a display in a 2D viewer. I can display as wiggle or as color display. So the color display will show me something like that. So like I just say, all those elements like inline, crossline, Z slice, random line can be shown as 2D viewer. So what we have in new here, we have, for instance, if you go to the display property, you will see we have can display your wiggle variable density, and annotation, axis, crossline can be displayed, X coordinate and Y coordinate as well. So let me just try to track some fault and horizon. I zoom that part below where we fault are clearly seen. Let me show another time a color bar, which will be a little bit clearer. Okay, grayscale. So if you want to create, for instance, fault 6 set, make some fault 6 set, right click new. So you have it here. So you just, this is actually new. Instead of clicking every time to make seeds, just one click and drag, you have your fault 6 set. One click and drag, you have fault 6 set. And here we go. You can do the same, or you can save your fault 6 set and convert it, or you can do the same with horizon. Let me just remove it. Horizon 3D new. You have horizon 3D new, and you start the line manual, for instance. Let's track this event here, like you can see. Instead of making seeds like we used to do, just a small simple click and drag the mouse will give you something like that. So this is just some few example on how, what is new in 2D viewer. Okay, let me display, remove my horizon, remove, and you can see horizon cube display. You can display your horizon cube. So this is just a display view. Let me go back. Yeah, you have it here. Sorry, because I had still the zoomed view with me. So if you can just see here, same thing for system track. Okay, you have your horizon display, and you can play with the horizon cube slider. Try to make any type of sequence stratigraphy interpretation. Sorry, I have a small delay here. So yeah, that is the way it works. So you can create here, let me cancel and show you the system track that we already made. So like you can see here, we have a system track. We just divide the sequence into different type of system track, fooling stage, transgression system track, and high stand. So you can yes, like you can see some milling phase going up here. Anyway, okay, so I can just close. And let me go back to the next topic. Next topic is the fault interpretation. In OpendTect, newly interpreted fault set or a selection can be transformed in 3D fault and vice versa. 3D fault, the user can output from 3D fault the fault set. This conversion is done using the newly implemented fault interpretation toolbar, like you can see here. This is a newly it's new in 4.2.0, so where you can being in edit mode or selection mode. So in edit mode, like here, what you can do in edit mode, in this mode, nodes are in yellow, like you can see they're in yellow. The user can add node by just click or drag, because click is old and drag now, and node can be dragged from one location to another. And in selection mode, like you can see, this is selection mode, this is edit mode. In selection mode, when this mode is active, fault and fault set are selected, copied, or moved. And the new or already existed fault group. So the output here you can make, I will show you the demo, just small demo now. So you can just, with all the fault set you have made, you can select. You will select, and then you can just click go. From your fault set, you will have fault plane. Let's demo this one as well. Let me go back to OpendTect. Still this lower area where we have some clear fault. Grayscale, color. Where are you? Okay, so fault set. So new. So like you can see now, the fault toolbar is now active in edit mode. This is a selected mode that I can explain, that I just explained, when you want to select a part or a part of fault set to convert into fault. So let's start just to do some quick demo here. Let me just be quicker. This is what we have. Let me go up to 220. Click again. I do just a quick, it's not precisely well, but it's just a demo. Let me go back again and okay, should always be active. click here, it's active, and then you can go on with your interpretation. Okay, so like you can see, let me just remove it, fault here, not clearly well. Let me go to property, maybe white color. Okay, here we can see it. So you were in edit mode, so let's go to select mode. I will select. Now you can see they have changed the color from yellow to pink. And when you will just select, let's just select this one, for instance. I select, I will just give it a name, my fault. And I click on go. So like you can see, from 468 we have just converted 468 to one fault plane. And here what I can do, I can select that part. Now we'll just be in it, go. So this one I can just save it as a fault for further work. This includes that part of the topic in fault interpretation. Export of cultural data to Earth browser. Survey boundaries, well, surface coordinate, polygon, and 2D and other type of cultural data can be exported as cultural data from OpendTect to an Earth browser like GoogleEarth. So like you can see here a KML file which we created, KML, which is a file format used to display geographic data in Earth browser such as GoogleEarth. So once it has been created, you have a KML file, and you click OK and go to GoogleEarth. You will see your data, your cultural data displayed. But if the KML file is not available yet, you will first, like here we see, first need to specify the correspondence between XY coordinate and the latitude, longitude coordinate. Let me demo that part as well. Remove. Okay, let's go to survey. We want to export survey boundaries. Select, survey select, and you have export to Google Earth map icon here. You will just click it, and you have your KML file here export clear. You can click OK and cancel. You can just do also the same with fault, with Wales, for instance. Wales, and you click and you dismiss. You go to your browser, Google Earth. So I will just open the file I've created. Open. In the same location, C survey. Let me find my KML. It should be here already. Survey bound. And for instance, this Wel correlation. Click OK, and the Google Earth will just show me the location of my server. Like I explained to you earlier, we are working here with F3 Dutch block in the North Sea. So like you can see the survey boundaries here, and this is a random line actually going through the whale. It is a KML file that have already been created and saved. So this is what it's the export of of cultural data all about. Next, the directional lightning. The directional lightning feature is used to illuminate display data at a specific inclination or deep angle and azimuth. The feature control headline, so like you can see here, we have, for instance, this same horizon, but with different inclination of deep angle and azimuth. You have different type of feature which has been displayed. How to use, how to open it, like you can see the icon here. Just this, sorry, let me just go back to show you where you can open it here. So you see set directional lightning, you have it here, and you can play with intensity, azimuth, deep, show polar, set azimuth and deep here. Okay, let me just go back and show you an example here. So here like you can see channel are being clearly, and here we have some long shore sound wave here from north. Here it's a little bit clear from different angle, different feature has been displayed. Here we see clearly that fault, and here it has been disappear. This is another example, like you can see here, something like fault-like feature. Here we have different kind of display. This is a property I can just show you earlier. You can fix the intensity from 6 to 80%. You can rotate your azimuth, fix the degree from 0 to 10, ambient light intensity, and many more. Wavelet tapering is next. A wavelet tapering window is launched by pressing this icon from the wavelet management window in OpendTect. A wavelet is tapped in time or in frequency domain. I mean, this feature is actually used in most of cases where you know that you have a wavelet which has been extracted in a noisy data. So you would like, for instance, to remove your side lobe, and yeah, depending on what you want, you can play with time or frequency. In time domain, the selected wavelet is tapped by selecting a tapering percentage, which is set from the slider available at the bottom of the window, like you can see as this tappered. While in frequency domain, here, the frequency domain, the tapping can be applied to both ends of an amplitude spectrum, high or low frequency. Sample multi-well import. This can be launched from survey import wells, where instead of importing one by one well, you can just open this windows. You can manually or create a file to import multi wells. So this utility windows will allow you really the quick creation of multi-vertical wells with a constant velocity, like you can see here, as a time depth model provider. So you can do it manually or create a file, and then in one go you have all your wells. Those are what you will really need: XY, well name XY, and Kalebushi elevation. The managed stratigraphy. The managed stratigraphy, actually, we have a change and improvement where you can show the time domain or the tree domain. You can see here. So in a newly implemented managed window, the user can notice that you can just move from time to depth depending on what you want, and you can set your regional marker and stratigraphy unit. Grading using GMT algorithm. The grading utility is used in OpendTect and everywhere, I think, to grade and interpolate an horizon. So from a horizon, just right-click algorithm and you click on grade. So there are several grading algorithms supported in OpendTect. Like you can see here, we had inverse distance, triangulation, extension. But now with GMT algorithm, we have continuous curvature and nearest neighbor. The continuous curvature is an algorithm by GMT, which is part from GMT plugin to OpendTect. This algorithm only requires a tension, like you can see a parameter, which range from 0 to 1. So it's like a similarity type of, if I can say. So the tension 0 will give the minimum curvature type of surface interpolation, while 1, the maximum, will give an harmonic surface. The nearest neighbor is also another interpolation coming from GMT. This algorithm requires the search radius of, like here, 24, for instance, to be defined. And it's mostly useful for regular, I will say, regularly spaced grid data. But for further information about these two algorithms, I will please refer you to check the GMT site. Google Translate. Google Translate, actually it's this utility use online Google Translator to enable the translation of text from OpendTect to Google. So the language, like you can see here, to be translated is selected from the language list box. Like here, GMT in Arabic tell us something like you can see here. A small demo. Let me just go to utility, translate. I will enable, I will choose Russian, for instance, and I will click. So here, like you can see, open workspace. It's something like OpendTect рабочее место. Like here, manage seismic data will tell you that it's управление сейсмических данных, and so on. You will just see управление скважин. So this is one of the newest feature in 4.2.0, especially for people who have some problem with English. They can already have an idea of what they are looking at. The multi-machine window processing, it's now we have Windows as well to be added for the multi-machine processing. Before it was machine. Like you can see in this example, we have Linux machine, and you have Windows with a ID machine, and you add, and new feature in OpendTect 4.2.0. So you can add your window machine as well for the multi-machine big volume processing. Probability density function. Like you remember in the beginning, I explained you that those are the feature I made in white because my colleagues already explained it. Like this one, for instance, my colleague Farouk Ayoum deeply show the probability density function in the webinar, I think, called crossplot. Webinar called crossplot, and the probability density function can be created from the crossplot toolbar icon. And this icon is launched from a pop-up dialog that can be used for selecting attribute in order to create PDF. And the PDF are stored in OpendTect format. That can later be used for running, for instance, Bayesian type of classification. So like you can see here from that seismic parameter we enter, this is what we can get we see density, gamma ray, and acoustic impedance. So by changing the acoustic impedance value, we see a different type of output. Like here we have oil and bright sound at the same time, and here we see some difference, bright sound, sorry, and here oil sound, for instance. The improved volume builder. This also has been covered, I think, by my colleague Arnaud Huck. You can look at the webinar, and the volume builder actually is a setup. The volume builder setup is used to apply volume-based operation. You can launch it from analysis, volume builder, and menu. So like you can see, there is a lot of steps that you can start. It's actually like attribute set for attribute. So the volume builder actually from volume, but from trace to trace input, you will need attribute set engine. But for volume, you'll need volume builder. So the setup is very useful. It's a very useful tool for grading velocity or other type of rock property. So it contains several available steps that are applied sequentially to generate a volume. Wacom digitizing tablet. OpendTect is the first seismic interpretation system to support Wacom digitized tablet. This is actually new. Workflow from horizon tracking, fault interpretation, drawing of polygon and body, you name it, have been adapted to benefit from that super hand-eye coordination, which is offered by the benefit of pen. So we have your pen, instead of clicking, you just, like I showed in the demo with fault and horizon tracking, just a simple hold of your left mouse and you drag, you have your horizon, and here also has fault, like my colleague Helen was explaining here in that image. So what's new as closed source? Because what I've just explained was where everything that anybody can have access. It's open source, but here it's closed source. So we have a local and structural display for a local CCB, which is new, and structural display also is new because we had a flatnet display. So like you can see, some few words about CCB for attendees who don't know. I would say that common contour binning CCB is a stacking technique which used to detect certain hydrocarbon-related seismic anomaly and to pinpoint zone of contact for like gas, oil, for instance, gas, oil, gas, water, and oil, water contact. So like in this image, you can see that we can expect that, okay, we have a contact here and contact there. So what is new is the display view, for instance. We had before the flatnet view in the 2D viewer, and now in the 4.2.0 we have an flatnet view. So the flatnet view along the mapped reference horizon and flatnet view. In the flatnet view mode, the structure is tilted, and that facilitates the recognition of flat spot associated with fluid contact, for instance. And the local common contour binning. So this is new, local contour, because we have what we call standard, and the local common contour binning is a new seismic filtering technique. It's like filtering which enhances fluid-related amplitude change in the seismic volume. This technique is based on stacking, so you have here like output statistic, average, or median. So The technique is based on stacking of seismic traces that are collected in a local area, which are controlled by top reservoir depth. So it's the result is just enhance the fluid effect recording in the seismic data without loss of actually the stratigraphy detail, like the case in the standard common counterbeaming. But this one, your stratigraphy detail will be just kept. Creation of peak set in a neural network we know. So actually, when you want to create a peak set, what we used to do is that you go to peak set, new, and you start making your peak set. Yeah, now I'm talking about the random peak set because manually, not random like from chimney cube, you will still need to make it manually. But I'm now talking about a random peak set that you can use from, let's say, UVQ and supervisor vector quantizer for the seismic phase map. So let's just a quick view here. You have pattern recognition peak set, and if you click on unsupervised, you will have here create. You don't need to select or to create it before. Now you can just go create to say, okay, I want peaks 1000 random for my seismic phase display. Here you make 1000 as you mentioned in the name, and geometry, say okay, I want it on the horizon, and you will select your horizon here like demo FS area sub-selection known, or you can use a polygon or something else. So this is actually new in 4.2.0 where you can create your peak set directly from neural network windows. The next topic will be the topic in white. Once again, now it's for the horizon cube, for the closed source. So those topics in white has been already covered in detail by our colleague. And this one for horizon cube, I remember that our colleague René Bourg and Paul Decote explain it in more detail in the previous webinar. So actually, in a few words, is that the horizon cube consists of a dense set of correlated 3D stratigraphy surfaces, and each horizon is each horizon in horizon cube represents a relative geological timeline. Horizons are created either by model-driven way, like stratal or proportional slicing, parallel to upper, parallel to lower, or in data-driven, where via a unique deep steering auto tracker. So you will create a deep steering cube, which is a cube contained deep in azimuth, and then at every sample position, and you will use it for horizon cube. And the result is that actually your stratigraphy surfaces will follow the geometry based on deep and azimuth instead of tracking using amplitude data. That with this new feature, we use deep steering instead of just amplitude data. So what you can do with horizon cube is, horizon cube impact all level of seismic interpretation, like you can see here. They are used for detailed geological model building. Here, geomodel. Low frequency model building for seismic inversion, Wel Correlation, and second stratigraphy, CIS, second stratigraphy interpretation. You can see here in the Wheeler transform, second stratigraphy and interpretation. Wel Correlation panel also deeply explained the previous webinar, but I will say that the Wel Correlation panel plugin is used for picking well marker and correlating a marker guided by seismic evidence. Here with seismic evidence we can use horizon cube instead. So in combination with horizon cube, the interpreter use the horizon cube slider for detailed seismic state correlation. So we correlate those, for instance, those three wells by using Horizon, Horizon Cube and Horizon. Yeah, that's all the new topic I wanted to share with you, and thank you very much for your attention. Back to you, René. Sorry, Petrol link. This is the last one. I think I already explained it. Just a link, exchange link from Petrol to OpenDetect and back from OpenTect to Petrol. Thanks again, and back to you, René.
Thank you, Eric. I think you've covered quite a few topics that are of interest to a lot of people, so thank you very much for that. In the last few minutes, I've had a few questions come in, if you'd like to address those. One in particular is asking, I'm new to the world of seismic attributes. What are the attributes I can interpret with a 2D data on the open source?
Sorry, can you?
It's somebody who's new to the world of seismic attributes, and they have 2D data, and they're wondering what attributes would be useful for them using only the open source attribute engine.
From 2D data.
Yes.
What type of attribute? But I think yeah, all kind of attribute can be used. Let me just go to attribute set and to see if just to show you the bunch of different type of attribute we use, and I think those are also used for 2D data as well. So you can see here now, for instance, even the RCLS, SCI, and seismic spectral blowing can be used for 2D, which is now new. Before it was just 3D, so seismic spectral blowing to enhance your seismic resolution by using the reflectivity data coming from well. And we have also different type of attribute here. I mean, a lot of attribute can be used from 3D as 2D. Yeah, unless I think most of attribute are 2D and 3D.
Yes, and somebody actually just pointed out in the question pane that you were looking at the 3D attributes. So just to clarify to our new user, we have a 3D attribute window and we have a 2D attribute window. So if you are working exclusively with 2D data, you can open up the 2D attribute window and see what is there.
Thanks. I didn't notice that I set up this server as 2D, 3D, so indeed we have a 2D attribute here, so it can be used to check what type of attribute that can be used using 2D data.
Yes, and we're actually having a few more. The panelists are chiming in via chat, listing out several, so I'll just go ahead and read those off real quick. 2D similarity, instantaneous attributes, spectral decomposition, neural network facies for 2D, let's see, convolution, mathematics, similarity. So yes, there's quite a lot. Everyone's typing in so fast I can't even read. Now, we do have another question regarding polygons. Somebody was asking if you can calculate a volume within a polygon. Is this now a feature that we can handle?
If we can calculate
a volume within a polygon. And panelists, I would like to remind you that you are all unmuted now, so if you would like to chime in, just unmute yourself on your end.
Yes, there is an option now that is computing the volumetrics from a polygon, and it's not doing this only from a polygon. It's actually computing the volumetrics using the polygon as a lateral extent and a surface and a 3D horizon.
Yeah, okay, thanks. Satisfied maybe.
Okay, and I'm also sending you a few of the questions that have come in, Eric, so if you can look in your questions pane.
Oh, okay. Oh,
Yes.
sorry.
Mm-hmm.
I did not. I forgot about.
We're actually just having people ask for briefly explain how the Wel Correlation panel works, and another person was asking explain a little more detail about the multi-well import feature.
Okay, about the multi-well importer feature, let me first just. Okay, I can just directly go there. Actually, what you can do is just you can go to survey, import well sample multi-well, and you click there, and this is what you have. You can do it manually, or you can create a file that can be read. So it's a quick correlation of multiple well with a constant velocity. It should be constant as a depth time model provider. So manually or by reading a file. The following parameters are mandatory. You have the well name. You have a position along x-axis and position y-axis, Kalibushi elevation, the reference datum, which is altitude measured from the sea level of the point at measure depth 0. And you have a total depth, which is the largest measured depth in the well. But here, SRD and URI, which is seismic reference datum and unique well identifier, are not mandatory. You can add them or not. So really, all those 4-5 columns you have to fill in something, but here you do not need. So actually, the good thing is that instead of importing one by one, you can just fill in and just with one file you have all your wells imported in one go. About the well correlation panel, let me just go and display. Yeah, so Wel Correlation panel, like I said, it was covered in previous webinar, but let me explain it to give you an idea of what it does. It's a new plugin, commercial plugin in 4.2.0, and it's used for picking well marker and correlated marker and correlating markers guided by seismic data. In combination with Horizon Cube, the interpreter use Horizon Cube slider for detailed seismic steric correlation. So you correlate your 3 wells by a seismic steering, if I will say. So how it works? So typically the user starts by constructing a random line through wells that are to be correlated, like the name say well correlation. So you create a random line through wells, and in the interactive 2D viewer, well logs, stratigraphic column, and seismic data, Horizon Cube can be displayed and manipulated. So yeah, this is what I can explain, but for more detail, I think we explained it in previous video. Just open and to look. And I will add also that the Wel Correlation panel support correlating in both depth and time domain. So time depth conversion and seismic to synthetic to seismic match are closely integrated in that package as well. So if you want to tie seismic to well first, synthetic to seismic first, you can do it. They are all integrated in the Wel Correlation panel. Yeah, I think that's it. Back to you, René.
Thank you, Eric. And actually, I just had a response come in from a student, the person who asked about the 2D as well, also wanted to mention that they were a student and they just now realized that they did not have to use the closed source, or that that the attributes were not closed source, that they could use them for free, and they're getting very excited about this. So if there are any other students out there, I would like to mention that you do get everything for free. Your university simply has to request and sign an academic license agreement, but you can have access to every single plugin for free. So please feel free to contact any one of us to learn more about that, but we also have the information on the website as well. Now I do have a question. It's a rather lengthy one. I'm going to send it over to you, Eric, so that you can read it, but I will also read it aloud. It says about the misclassified picks in the neural network classification. In 4.0, some of the misclassified picks would show out of the line, and it was difficult to know which was the actual pick that was misclassified. Has this been changed in 4.2 to make it easier to correct or delete the correct misclassified picks in the pick sets?
I really did not notice that we have that problem in 4.2.0, because usually when me, for instance, when I'm doing, for instance, a chimney cube, neural network chimney cube training, I have my misclassification picks, which are different color than the other pick, the pick yes and pick no, pick yes for chimney and pick no for the background. And the misclassification has always, they have a different color, and I can see them clearly, and based on that I can change my input pick set again. So I don't know if other have noticed that problem, I don't know, but for my side they were always in different color, and you can see them clearly, and yeah, this is what I can say, but I will check and see if, but in 4.2.0, of course, everything has been improved, I think, and so what I would advise to the person who asked a question, just download our latest version, and please do the same neural network training again, and if you have the same problem, please just send us an email to support or to me, and we will try to see what you can do about it.
Okay, I will see if we get any more questions in, or if this also if this answer was sufficient to the asker. So please let us know. They said thanks, multiple exclamation points. So that's nice. Now I'll give people a few more minutes to go ahead and send in questions if you do have any. But while we're waiting on that, I want to go ahead and thank our presenter, Eric. We've also had some comments saying that people think it's really neat that you speak English, French, and apparently Russian. So it was a nice treat for everybody.
Thank you.
And for everybody else, this webinar will be available online in just a few days, so you'll be able to watch it again and send the link to your colleagues. But I would also like to mention one of the great things about this being open source is, and the company mentality that comes with that, is that people can send in questions, people can send in suggestions. We actually, if you're not on the user's mailing list, you really should sign up, because on the user's mailing list just last week we had somebody ask a question saying, wouldn't it be great if we could do this sort of thing with GMT? It was about the coordinates that the output was in. Currently there's one option and they were looking for another option. One of our developers replied back saying, you know what, I think that would be useful to everybody. We will implement that in a later release. So it can be as simple as that. If you have a request that you think would be useful for everybody, then please send it in. It may become part of the next OpenTect. And also we had somebody else saying, if this functionality is not there, let me know and I'll build it, and I want it to be part of the open source software. So please keep on sending your ideas, and if you would like to donate something to be part of OpenTect, please contact us and let us know. On that note, next month's webinar will be for the programmers. So next month, Christopher Tingdahl will be showing us, talking to us about parallel programming. So please do join us in July for that webinar. All right. Well, we don't have any new questions coming in, so I would like to thank our panelists and our presenter. Thank you for joining us today, being attendees, sending in your questions. Thank you for participating, and we look forward to everybody joining us next month. So have a great month.